Hello friends, today we are going to study about atoms. So first we should know what are atoms. Atom is the basic particle of any chemical elements. It consists of nucleus and layers surrounding those nucleus. The nucleus consists of protons plus neutrons and electrons revolve around the nucleus in layers. If we see to the mass of these elements, we'll find that proton and neutron carry almost similar mass. But if we see the mass of an electron, we'll find that a mass of an electron is very negligible as compared to the mass of a proton or a neutron. Mass of 1840 electrons to the mass of a one proton or one neutron. But the charges, neutron does not carry any charge, but the charge present in a proton and electron are same and opposite. Now come to the atomic numbers. Atomic numbers depends upon the number of protons. Therefore, in the atomic number, as because the number of protons is not changing, the identity of the element remains the same. Identity of the element depends upon the number of protons it carries. For example, we know carbon. We call it as a carbon 6. Atomic number of carbon is 6. Why? Because carbon carries 6 number of protons. Though it also carries neutron 6 and electron 6, but still this 6 atomic number 6 comes from this proton 6. So atomic number depends upon the number of protons. Okay, so if we change the proton number, then the identity of this element will change. For example, if we take nitrogen, right, it is 7 because it contains 7 protons, correct? So when the number of protons change, plus 1 7, the identity also changed from carbon to nitrogen. Okay, so what are atomic numbers? Atomic numbers depend upon number of protons and it represents the identity of an element, correct? Now, if we change the number of electrons or neutrons, it does not affect the identity of an element. For example, magnesium. Here, the number of protons in magnesium are 12. Electrons are also 12. Neutrons are also 12. This atomic number 12 comes from number of protons. Now, what if the number of electrons changes? Here it was 12, here it became 10. That means it donated 2 electrons. Hence, it becomes Mg2 plus because it donated. Donation is a good thing. To help somebody is a positive character. So it becomes 2 plus. Okay. So magnesium 2 plus. But the identity magnesium, when the number of electrons is 12, it is still the magnesium. When the number of electrons is 10, it is still the magnesium. Here it is magnesium, as because it donated 2 electrons here, it becomes Mg2 plus, but Mg remains Mg. Why? Because the number of proton is same. In both the cases, they have 12 protons. Understood? So, number of proton is important for the identity of any element. Correct? Now, in the example 2, this is the normal isotope of a carbon where atomic mass is 12. Here atomic mass is 13. Why? Because in carbon 12, what is happening? Number of neutrons are 6. In carbon 13, number of neutrons are 7. So when the number of neutrons are changing, like from 6 to 7, what is happening? Atomic mass changed. Here it is 13, here it is 12. Understood? So until and unless we change the number of protons, the identity remains the same. Correct? If we change number of electrons, then it will become, if it is donating, it will become plus. If it is accepting, it will become minus. Like Cl minus. Why? Because it accepts an electron. Correct. So that means if the number of electrons are changed, that is because it is donating or accepting, but the identity will remain the same. Similarly, if number of neutrons are changing, that means atomic mass will change. Why? Because atomic mass, I told you already that atomic mass is equals to number of protons plus number of neutrons. Atomic mass. Atomic mass is a mass of a nucleus. The nucleus of atom are made up of protons plus neutrons. So number of proton plus number of neutrons will form the atomic mass. Correct? In this example, magnesium, number of protons, how many? 12. Number of neutrons, 12. 12 plus 12, 24. So atomic mass of magnesium element is 24. Here again the same example, carbon 12 and carbon 13. We already understood why this is 12 and why this is 13, because number of neutrons are changed. Here it is 6 number of neutrons, here number of neutrons are 7. Understood? Easy. Now come, what is atomic weight? What is the difference between atomic mass and atomic weight? Atomic mass means mass of a particular isotope of an element. Correct? Like carbon 12. This is the mass of this particular isotope, carbon 12 isotope. Carbon 13. This is atomic mass. But what is atomic weight? In nature, carbon 12, carbon 13 and carbon 14 are found naturally. These are the three isotopes of carbon which are found naturally. So when we take the weighted average of atomic mass of all the three isotopes, we'll get atomic weight. Okay, see the example, carbon 12, carbon 13 and carbon 14. The availability of carbon 12 is 99%, the availability of carbon 13 is 1% and carbon 14 is less than 1%. Atomic masses are 12, 13 and 14. Correct? So how we'll calculate atomic weight? Atomic weight is 12 into its availability 99% means 0.99 plus 13 into 1%, that is 0.01. 14 we have not taken because it is less than 1. So it will be very negligible. Correct? So after calculating, the atomic weight comes for carbon is 12.01. Got it? The difference, atomic weight is it is a weighted average of all the naturally available isotopes in the environment. Atomic mass is the mass of a particular isotope of an element. Understood? Next is atomic mass or weight unit. What is the unit of atomic mass or weight? It is atomic mass unit AMU or simply unit or Dalton or gram per mole. 1 AMU is 1/12 mass of a carbon atom or mass of one proton or neutron or mass of a hydrogen atom. These are relative units. Relative means we always compare and say, like for example, two persons are standing together. So we'll say like this person is taller than this. So these height is always a relative value. Among these two, this person is taller. Maybe if we compare this person with somebody else who is taller than this one, then we will say that this person is taller than this one. So these type of characters are always relative. So similarly, this atomic mass or weight unit, these are also relative units. We compare, right? Here it is written 1 AMU is equals to 1/12 mass of a carbon atom. Correct. So we are comparing it with the carbon. Mass of any element, we are comparing with the mass of a carbon, 1/12 mass of a carbon. Okay. Isotopes. What are isotopes? Iso means same. Topes means position. So isotope means same position. You can remember it with this alphabet P for proton. That means isotopes are the elements having same number of protons. When the protons are same, that means atomic number will remain the same. That means element identity will be the same. Correct? We already learned this. Correct? Now this is an example of hydrogen, H1. That means one proton and zero neutron. So we call it as a protium. Then if one neutron is present, then we call it as a deuterium. If two neutrons are present, then we call it as a tritium. Okay, so these are all the three are H1, H2 and H3. These are isotopes. Correct? But what we noticed along with seeing that number of protons are not changing, apart from that, what is noticeable is number of neutrons are changing. Correct? And what we learned, atomic mass depends upon number of proton plus number of neutron. If the proton number is not changing, but if the neutron number is changing, that means atomic mass will definitely change. So isotopes will have different atomic mass but have same atomic number. Understood? Next, isobar. Iso means same. Bar, remember it from this alphabet A, that is same atomic mass. Okay, but they have different atomic number. Correct. So when we are saying different atomic number means number of protons are definitely different. Correct. Number of neutrons doesn't matter, it is different or same. Correct. But number of protons should definitely be different. If the number of protons is different because atomic number is different, that means element's identity will also change. So here carbon 14 and nitrogen 14. These are isobars. Number of protons 6 here, number of protons 7. Change in number of proton, hence the identity changed. This is carbon, this is nitrogen. Number of neutrons, here 8, here 7. Correct. 6 plus 8 is also 14, 7 plus 7 is also 14. Hence they have same atomic mass. Correct. But because number of protons are different, their identity change. So carbon 14 and nitrogen 14 are isobars of each other. Got it? Next come to isotones. Iso means same and tones you remember with N. Same number of neutrons. Correct? Now, they have different number of protons. Again, when the proton number change means atomic number will change, means the element's identity will change. Okay? So example here is oxygen 16 and nitrogen 15. Here number of protons are 8. Here number of protons are 7. So they have different protons. That means their identity changed. Here number of neutrons 8. Number of neutrons 8. So number of neutrons should be same. Clear? Isotopes means number of protons same. This is isotope. Means number of protons same. Isobar means from A. Atomic mass same. Clear? Isotone from N you remember. Number of neutrons same. Only in isotopes the identity of an element is conserved. It won't change. But in isobar and isotone, in both the cases, element identity is going to change. Radioisotopes. Isotopes we learned same position or same element, we can say same element. What are radioisotopes? The isotopes that are so heavy that they are very unstable in that state. So to be stable, they'll emit some radiations. So the isotopes that will emit any radiation is known as radioisotope. Why they will emit radiations? Because in isotopes number of protons same, but number of neutrons are different. So their mass number will be different. Like carbon 12, carbon 14, they have different mass number. Correct. This 14 is unstable. Why? Because it contains extra neutrons. So it became very heavy. So it wants to be stable. So how it can become stable? It will emit radiations. Okay. Now, what are the radiation they can emit? They can emit alpha rays, beta rays or gamma rays. Clear? Now, if an element emit alpha rays, then what will happen? If an element emit alpha rays, that means a helium nucleus will be emitted out. If a helium nucleus is emitted out, that means in atomic mass there will be a change of -4. Atomic mass will decrease by -4. What will be the change in atomic number? -2. Clear? If any element is emitting beta rays, then what will happen? The particles, the main particle which will be emitted will be electron. It's a negatron actually. What change we will notice? In atomic number, it will become +1. For gamma rays, it is a photon. No change in atomic mass, no change in atomic number. If we see the mutational or penetrational property, we'll find that gamma rays are much more mutational and penetration power compared to beta and compared to the alpha rays. Clear? Now here, it is given and radioisotope carbon 14. Number of proton is 6, number of neutrons are 8. It is emitting beta rays. We studied 3 rays, right? Alpha, beta and gamma. There is no change. Here is +1 in atomic number. Here is -4 in atomic mass. minus 2 in atomic number. So here beta rays, right? So that means plus 1 in atomic number, correct? So carbon, plus 1 means number of protons from 6 is going 7. 7 means nitrogen. So carbon 14 will convert into nitrogen 14. Now, these radioactive elements, as because they emit radiations, they are very helpful in biological system because it works as a marker. Okay, because they emit radiation, so they can easily show presence. So it works as a marker, correct? So here are few examples of radioisotopes that are used in a biological system, like cobalt-16. It is used to stop the development of cancer cell because it emits gamma rays and it destroys the cancer cell. Iodine-131, it is used to treat hyperthyroidism because it can help in destroy thyroid cells. Carbon-14, it is used to identify ulcer-causing bacteria, that is Helicobacter pylori. So what we do is one capsule which contains carbon dioxide. That carbon dioxide is a carbon-14 tagged carbon dioxide. And as soon as the person or the patient engulf this capsule, if that person is having Helicobacter pylori infection, so this bacteria will release urease. As soon as it will release urease, what will happen? Because the capsule is urea capsule, it will break open. And as it will break open, it will release carbon dioxide. As because it is carbon-14, so we can detect this particular carbon dioxide in an exhaled breath. So these are three examples of radioisotopes which are used for biological system. So that's all for atoms. Now one question which you have to answer me in the comment section, that is how and where we can use the property of conversion of carbon-14 to nitrogen-14. It's very easy. I know definitely you all will have this answer, but please do write in the comment section. So that's all for today's class. If you like the video, then please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay blessed, stay happy.